Continue screen share.
Yeah, great. Okay, so today I'm going to tell you a bit about Qualoo and what we do, and we're using Web3 to solve one of the biggest real-world problems, and that is helping people to get better internet all over the world. So I'd like to go over a few things in my presentation. So one of the things is why global connectivity matters, and a bit about my personal journey, how I ended up as a founder of a Web3 company trying to tackle one of these huge issues. Some of the systemic issues that are actually going on around the world with global internet. A bit about what DePIN is, because I think not everyone knows what the term is and how it is put into use, and a bit about how Qualoo actually uses that DePIN model to make the internet better for everybody. We also want to go into the real world impact of what we're trying to do, our vision for the future, and how everybody can get involved, run a Qualoo node and become one of the guardians of the internet. So a bit about my personal background. I started off working for British Telecom. I started as an apprentice straight from school. I spent a lot of time engineering out in the field, learning about cable jointing, fault repairs, maintenance. After that, I went into network planning, designing networks, understanding how the networks are built, put together, and this really set me on a good course for going to work internationally as a global telecom consultant. So I did projects in Europe, Middle East, Asia, and Africa, pretty much helping telecom providers improve their internet, looking for the reasons why they have bad service. And during that time, that led me to realize there's such a huge problem here that nobody can really solve without a drastic new solution. And that's what led me to founding Qualoo, which was that solution to try and help everybody get better access to internet. Okay, so the type of projects that I typically worked on during this time was working with internet service providers, telecom infrastructure providers, governments and regulators, usually where the population is suffering with really poor internet. You have lots of complaints, faults. I'm sure everyone here has understood how frustrating it is when the internet doesn't work. And that costs a lot of money. For the telecom providers send a lot of technicians out, that costs a lot of money. When customers aren't happy, they cancel the service, and a lot of these telecom providers actually just spend money in their own places. And it was my job throughout all those consultancy projects to really find out what was going on, help them to work through their issues. But it was during this time that I found that it was virtually impossible to understand what was going on. The internet experience changes like the weather. It's not something that can be easily understood by looking at typical fault analysis of fault complaints, reasons why customers would cancel their service. Also, when people complain about their internet service, it's completely subjective. Some people might be using it for gaming, some for video streaming, some for business. Everyone's got a completely different perception and expectation, and that was really hard to understand when you just look at the fault complaints en masse. The other problem that we discovered was that telecoms monitoring solutions, as they exist now, they don't really look at the internet as we use it. They focus more on system resources, is the network up or down. They don't really look at if your video streaming or game is working properly. And then probably the biggest challenge that we faced when we were trying to understand this was there's a huge gap because telecoms providers don't actually sell internet. Us as consumers think we are buying internet, but all telecom providers do is sell the pipe to your house, and that's why it's often just measured in the download speed. And because that's the only thing they really sell, that makes it very hard for regulators to look at anything other than that. So when we complain about that internet experience, it's just like falling on deaf ears because that's not what they sell. Now, the cost of all these problems is actually huge. There's hundreds of billions of dollars annually wasted by telecoms providers all over the world. hugely cost the businesses for downtime, and the overall telecoms cost of operation cost is $1.5 trillion. And then when you look at the problem with connecting everybody globally, we still have 2.6 billion people that haven't got internet at all, or they have really poor internet quality. So this was a huge problem that we needed to address, and we were struggling on consultancy work to make any impact at all, because any provider that you work with is just on such a tiny part of the overall internet. Even if you improve things on a small scale inside their network, you're not really impacting the entire global internet. So during this time, we figured out that we needed to develop a new way to actually measure internet quality. How do we even test it? And we learned during this time what kind of internet test you need to do. You know, it's not speed test, it's a lot of other things. You need to do lots of different tests, understand how service providers are actually routing your traffic. Is there any congestion in the networks? Is there any kind of policies that you're implying that can cause you to have a bad experience? And during this time, we really kind of learned our secret recipe, how we can quickly diagnose issues with broadband networks. And we've gone through lots of versions of hardware devices, right up until the modern day Qualoo node, which you can see on the bottom right of the screen there. And this is basically what we are trying to put out now all over the world. This solution that can really make a difference to global internet. So a typical example, when we were doing a consultancy project, we would actually put boxes in customers' homes. You can see a couple of examples here. These boxes would perform tests to popular applications, services, like banking industry, banking websites, Netflix, YouTube, gaming, all of the kind of common things that a typical internet user would do. And then we can pull all of that data back into a database and to derive insights from that allow us to visualize that network performance. So there's a lot to kind of take in here, but if you just look at the kind of the chaos of the lines going up and down, you can see that this is what happens when your internet is having a problem and you're having a bad experience. There's so many different things inside a network that can go wrong. And quite often when users are just using a speed test, they're just testing the very bottom part of the network. This means that they can't see any issues that are going on in the internet, anything that's impacting the entire planet, country, region, sometimes, often large numbers of customers in a single network. And the way that we do things different is we actually test end to end and all over the world, not just in a small part of the internet. Okay, so when we deployed these old models on consultancy projects, we thought it was really good. It was probably one of the only useful data sources that we could use to find problems. But it was a huge problem that it wasn't scalable. You know, it was way too resource intensive. Okay, so the other problems that we had was when we deploy devices as part of a project with a telecom provider, that telecom provider doesn't want anybody else to see the data. So the data is hidden, it's closed, it can't be used for any other purposes. The other thing is the reach was not very good. If you're just deploying devices inside one telecom provider's network, you're not looking at the entire internet. You're only looking at a very tiny portion of things. Also, this was massively time consuming. You know, you had to go out and install devices in person. You had to drive to people's houses. You had to convince people to plug the box in their house and answer all of these questions. And this also meant there was a lot of additional cost. That meant there was a huge cost to try and get those insights. You know, so you think your consultancy days are very expensive. You have a lot of logistics, expensive system licenses, which also made it impossible to do on a global scale. We also found another problem with a lot of organizations, they didn't really want the truth to be known, so if the telecom provider was giving bad service, they wouldn't want the regulators to know, they wouldn't want the customers to know, and in a few instances that led to projects not going ahead because they were scared of political fallout and things like that. So we needed to change the model here. We need somewhere where we can actually have ownership of the data side ourselves. We also need to have data across all providers, not just one or two service providers. So every country, every telecom provider, mobile, fixed, you name it. We also needed the data supply to be constant, which means always available, not just during a few month audit. So it had to be cheaper, it had to be always on. And we needed to crowdsource the data, not just the data, but also the hardware as well, because it would be impossible to actually pay for these devices for the whole planet. Who's going to pay the budget? How are we even going to speak to people in another country and convince them to just be such a huge headache to do that? And we need it to be permissionless and censorship resistant, so we don't want it to be a way where a telco can shut it down, or a government can say, we don't want to publish that because our internet is really bad. So this is all of the requirements that we had and how we actually ended up with using a DePIN model, as we know now. So the solution that we came upon was to have an incentivized, crowdsourced infrastructure model, which is now known as DePIN. So DePIN stands for Decentralized Physical Infrastructure Network. And this is a network that's actually built by the people. They actually pay that for the devices themselves. They run and maintain the network. And in return for doing that, they actually get a share of the network rewards. They actually get paid to do that. Now, this unlocks all of those magic things that we wanted to do. This means that the data ownership doesn't belong to any country, no single provider. It actually belongs to the Qualoo network in our case. And for the reach, this now gives us the ability to tap into a true borderless model where we can be in every country across all providers and technologies. Anybody can run a Qualoo node or download an app, and this can provide access to your location and your provider. This model also means that the network is always on. The people pay and run for the devices. It's a small cost, but it's always on. There's no expensive third-party licenses. It's all built and owned by the people. And the same for the cost of infrastructure. We don't have to outlay hundreds of millions of dollars building dedicated devices and logistics programs, because everybody buys a little bit of their network and it grows over time. So this shared cost means that we can actually spin up a global network in a way that we could never do previously. And all of those logistic headaches that would be so time consuming and resource intensive, like drive testing, shipping devices out, running, installing them, sending technicians, that again is replaced by the crowdsourced model. And because all the users of the world plug the device in their own network, not inside any telecom provider or government building or anything, this creates real accountability and transparency. We don't need any permission, we don't need to install any equipment inside of a telecom provider. So that means by running a Qualoo node, that shines light into your area on your telecom provider, which is really important for creating a new standard that the entire planet works towards. So once I came to this realization back in 2017, I wrote the early white paper for the Qualoo network and QXT, which is going to be our Qualoo experience token. The idea was that we could create devices that people own and we pay them to use their resources. The early model, I was thinking of using something like Ethereum, but in the early days it was very expensive, to run transactions and things like that. We didn't have the scalability that we have with modern day blockchains, layer 2s, and now we have dedicated blockchains that have functions for these DePIN networks, these crowdsourced infrastructure networks. And the other big revolution that has enabled this to be possible now is with Web3 and the community-driven networks is we now have a way where people will actually talk and support networks, support protocols, help run networks nodes and help promote projects, and that's something that doesn't happen in any other business model. So this DePIN model is really transformatively, it's going to change how networks are built. The legacy way of building networks relied on one single source, usually a centralized telecom provider or government. It needed a huge outlay of capex, was very labor intensive, had high maintenance costs, and it was usually very slow to deploy, whereas now doing it the decentralized ways, with people being able to buy their own hardware, whether it's a Wi-Fi router or a GPU or something that can be used by multiple people, anybody can build and buy equipment and create their bit of the network, and in return for that, they get paid to use them. So it's really going to change how things are done. So the DePIN model also uses something called a flywheel. It's how we can demonstrate the dynamics of how this works. So we create a token that is going to be used to kickstart the network investment. That token can be used as an investment vehicle to bring in investment to start the project off. That investment can then be used to build nodes and the network, build a network. Users who build and run nodes on the network will earn the tokens as their revenues and earn it for doing that. In return for doing that, the network will start to perform some functions. In our case, network analytics and diagnostics. It will enable developers and third-party applications and use cases to come into the protocol. And then that leads to customers coming in and paying for the service. And then that leads to more return for investors. And the economy is kind of kickstarted that way. So it's a little bit similar to like how a Kickstart model is done, but using tokenomics and a tokenized approach that doesn't rely on any major capex investment. And the beauty of this is you can actually do this on a global scale, not in any particular country or any jurisdiction, and that is very important for something that we're trying to do with improving the global internet, because it's borderless, it's in every country of the world. So the DePINs are going to be everywhere. There's lots of different use cases for them. Some of them have dedicated hardware. There's some examples here. A lot of people might have heard of Helium. They were one of the first DePIN crypto tokens for running IoT devices, and now they've repurposed their network to create 5G mobile coverage, where users can buy essentially a mini 5G mast, plug it into your own network, and you can earn rewards as people use the network. Demo is using the DePIN model to connect to people's cars. We use those insights for new insurance models, data analytics. You've got HiveMapper that has the dedicated speed camera that you stick on your car. It's mapping the roads in real time, looking for road signs, hazards, and creating new alternatives to Google Maps. The IoTex Pebble is dedicated hardware that has like environment sensors, GPS, and wireless again is looking for IoT connectivity, and then Qualoo fixed and mobile node, which is going to be mapping the entire global internet, diagnosing issues real time, and helping all of those internet stakeholders get better connected. So a little bit more into what we do and how we use our DePIN. We're essentially mapping the entire internet. We have two types of nodes. We have mobile app and a fixed node. These apps essentially are creating the Google Maps of the internet. We're mapping the roads, we're mapping the routes, we're looking for things like congestion, and we take those insights, we analyze them all, and we pipe them direct to like internet service providers government regulators, so they don't need to send technicians to diagnose problems. But we also can tell the end users how to get better connected. So it's a complete transformation to how things have been done before. Now the internet isn't just how you get connected in your local town or village. The internet is global. And here you see some examples about how the major internet exchange points within Europe, South America, New York, Americas. This is how the internet is put together. And when we map the internet, we test out from our devices to all of these different locations all around the world. We're mapping how that traffic is sent. Any problems that we see along routes, we can take that out and put them to the responsible party. And in doing that, we can really create accountability and transparency to help everybody. So one of the key functions of the network we're building is we're building a single network that is going to govern the entire internet and all networks. So we have fixed node, which is for your home internet, your office internet, and the mobile app, which is doing the same kind of thing for Wi-Fi networks and mobile networks. And we're building on a blockchain called IoTeX, which is a special kind of blockchain for DePIN projects. They don't just have a layer 1 blockchain that's very fast and very cheap to use. They also have a lot of security modules and features that is very useful for building a decentralized physical network, like being able to register the network, register the nodes on the network, making sure that those devices can be verified, proof of ownership, and where they are installed, where they say they are, and the data is provided without corruption and without being edited. So these devices will provide data back to our platform, and these nodes will earn rewards, revenues for their node operators, and that will be in QXT, our crypto token. So the other feature of our platform is the actual mobile app. This is going to be more than just another network node that's testing internet experience. We live in a time now where it's so important to be connected all the time. It's going to be even more important in the future. And we really want this mobile app to be almost like your connectivity assistant, whether you want to know which hotels got the best internet when you're traveling, which SIM card to get, which provider to get based on your use case, whether you're a gamer, a video streamer, there's different outcomes for that. And actually taking a lot of the challenges with delivering good quality internet in the fact that not everybody is an expert. People might not set their home Wi-Fi up correctly. There might be issues in the home that are impacting service, and to have kind of the AI diagnostics and chat features to really help non-technical people address their own challenges while recommending how to get it connected as well and get paid for it in the process. So one of the big surprises that a lot of people see is that we don't need that many nodes to really map and diagnose a lot of the issues in a country or provider. So we're aiming for at least 500 nodes in each country. Then that would stretch up to 1,000 to 5,000 nodes, depending on how big the country is. This would give us all of the insights that we need to find the major issues, make sure the telecom providers are actually delivering good quality service for its users, and everything works well for them. So we're actually looking to onboard users to these node operators, and we have on our website a waitlist at Qualoo.io that you can visit to register to be one of the first node operators. Okay, so building on the solution that I mentioned earlier, our network is also going to not just be a DePIN at its source, it's also going to have AI-driven analytics, it's going to have a platform that people can log into, get their insights as well. And this is really going to automate the whole process of the global bulk diagnostics, optimizing the internet, and being used not just for improving, the internet that exists there, but also recommending where to invest, and that's going to lead to, billions of dollars of savings on OpEx and much improved investment targeting. So the network itself is actually going to be an asset that can be used for different things. So if you think we're going to build this global network, it's going to be in every country in the world, we're going to have fixed devices and mobile devices. These devices can generate data and run certain jobs that can provide additional revenue. So these will be B2B services, B2B government as well, consultancy support and API access for people to use. And for the consumers, we're going to do node sales, we'll have the mobile app, premium subscriptions, affiliate advertising programs, and customized testing. So there's a lot of ways that the network can generate revenue. So the token itself is actually used in different ways. So the QXD token rewards the participation and funds the infrastructure. It also sustains the marketplace for people to come and buy and sell the different services that can run on the platform as well. And as we get revenues from the traditional businesses like telecom providers, governments, enterprises that are not Web3 friendly yet, we can take that revenue, purchase the QXD token on the open market, and then distribute back to the node users. So it's another way of users who run nodes to get more benefits from running our nodes. Yeah, so when we talk about the kind of real world impact, we've already demonstrated this in multiple cases on the consultancy, but also as Qualoo, we did a project in Brunei where with less than 40 devices deployed, hardware costs of less than 2,000, we identified major issues that was impacting the entire country. We did that in 24 hours, and these issues were running for years, 2-year-long issues impacting banking industry, gaming. A lot of users couldn't access the games they want to play unless they connect VPN. Huge issues that had wide-spanning impact on the country that was resolved in less than 24 hours. And this is the same value that we're going to get by deploying the global network. So once the product network's deployed, these things won't happen anymore. When new problems come onto the network, they'll be able to be instantly deployed, instantly detected. Those insights can go to the telecom providers, and they can fix it straight away. So shortening that timeline from years to hours has a huge global impact. Off the back of the work we did with Brunei, we also won a tender to write a quality experience framework for ASEAN, where we pretty much spelled out the vision for the quality network, how an open platform is needed to generate insights for all stakeholders to work on. And that's been adopted by the 10 governments in Southeast Asia. So once we roll out the network, which we're going to probably start in the next few weeks, we're going to start to onboard all of these government telco clients off the back of that vision to really give them the insights that they need. So looking at the big vision of where we see Qualoo fitting in, we see that as Qualoo as a single source of truth that's powered by our global DePIN network that supplies insights to all internet stakeholders. So we're talking about all telecom providers using Qualoo network at some point in the future, all government regulators as well as small, medium-sized enterprise clients using it, especially those that rely on internet for their day-to-day operations. And then we also see the mobile app getting hooked up by tens of millions of app users who have issues with the internet, want to get better connected, and just want to help map the internet and help everybody get the internet together. This is a time when it's never been so important, so it's really important the time is now. And when we look at the cost and how much money is being spent globally on improving the internet and actually on telecoms insights, we're very bullish on the network and what it's going to be able to achieve on the revenue as well. There's 20 billion being spent on telecoms analytics, 14.5 billion telecom consultancy market, huge amounts for expertise and insights, as well as being able to provide location-specific analytics is very important and huge growing business line. 31 billion for location-based analytics. And as part of the wider push for transformation, there's $3.5 trillion due to be spent by 2026. That's an all these initiatives, governments, telecom providers, improving networks, new networks. So we really see ourselves as the driver, driving and keeping all of this on track as well. So just a little bit on our roadmap as well. We're in fundraising stage now. We're actually raising 5.25 million to accelerate this roadmap. That plans is going to develop the product quicker, a big focus on marketing, getting out and on board those early telecom and government plans. We have a kind of a 2-year target to hit 20 million revenue with 5-year goal to grow over 100 million annually. So we have quite aggressive timeline and roadmap now. And yeah, so that's the end of the presentation. And let's make the internet better together. You feel free to reach out to me on Telegram or email keith@qualoo.io. Also visit the website qualoo.io and fill in the waitlist to be one of the first node operators. And we're also looking for investors, supporters, and early node adopters. So stay tuned and let's make the internet better together.